In this video, we're going to add 3 methods to the AList class. So we're going to add a method to swap 2 entries on a list, to move the first element on a list to the end of the list, and then a method to create a new list of entries that are all less than a particular element that's on the current list. Okay, so we're going to start with the moveToEnd method. And again, as a reminder, before you go ahead and add any new methods to a class, you want to make sure to have a really strong understanding of the existing methods, the existing instance data variables, because you'll need to use those in your methods. So you want to make sure you really have a strong understanding of how they work. So we're going to create a method to take the first item on a list and move it to the end of the list. You could maybe think about some instances where that might be useful. You know, somebody gets bumped out of line and moved to the back, or something that's waiting to be done now has a lower priority, so you want to take it off being the first thing on the list and put it at the end of the list. So we'll think for a moment about what our return type should be. For now, I'm just going to mark it as void, and I'm going to call this method moveToEnd. Now, you don't need to give me any parameters because I have all the information I need to do that. There's nothing else I need to be told. So inside my method, the first thing I need to do is what? Well, I need to make sure there's something to move, right? So I have to have at least something on my list. If my list is empty, then there's nothing to move to the end of the list. And so I don't want to do anything. But I don't want to just check actually that it's empty, because I also don't want to do anything if there's only one item on my list, right? Because if there's just one thing on my list, it's already at the end, so I don't have to move it. So I can actually save myself some work there. So what I really want to check is I want to make sure that number of entries is greater than 1, because that's when I have to actually do some work. Now, if that isn't the case, we could make the argument that you just don't have to do anything, right? If someone invokes this moveToEnd method on an empty list or on a list with just one element, we could just do nothing, or we could throw an exception. I think if they invoke this method on an empty list, you could make the case for throwing an exception. If someone invoked this method on a 1-element list, that's not an invalid thing to do, so you definitely should not throw an exception in that case. We're just going to make the decision not to do either, to throw an exception, or to not to throw an exception in either case. So we will just leave off the else statement for now. Okay, so if our number of entries is greater than 1, then we want to do the work of moving to the end. So if we wanted to directly modify the array, what we could do is we could take the element that's at position 1 and put it into what position? Well, currently the last element, or the last item in our list, is in the array position at number of entries. So what we could do is we could say the list at number of entries plus 1 is now going to get whatever is currently in the list at position 1, right? Because remember, we're leaving list at position 0 open, so the first thing on our list is in position 1 in the array, so we want to move that to the end. And then we want to do something like this to kind of make that first position empty. But then we don't want to just leave that empty. We want to actually shift everything down so that the current second element becomes the first and the current third element becomes the second. Well, that seems like a lot of work, but it seems like work I've done before. So what I could do is I could call my private helper method remove the gap. We would satisfy this precondition. We'd be sending in position 1, right? Because we want to move the gap that we just created in the first position. And 1 is less than or equal to 1. Is less than number of entries given the check that we just did in our moveToEnd method, so we'd be satisfying the precondition. So we could call remove the gap, sending in position 1. Now the only other thing that this method doesn't do is it doesn't check to make sure, for example, that we have enough space at the end of our list to do this. Because what if our list is currently full and then we try to add something to the end of it? We might run into a problem there. Now, in the way that this class is designed, we always enlarge our array after an addition. So that shouldn't happen. But we might not be confident that that's how it's going to work, or maybe we're working in another class where the expansion of our array happens prior to an add. So one thing we can do is some of this code we've already kind of written for. So what we could do in our implementation is, instead of directly accessing the array like this, we could say, all right, well, what I'm actually trying to do is remove the element at position 1 and then just add it to the list. And now I don't have to worry about directly invoking any private methods. I know that however this remove method works is going to work properly by taking something off the list. And then I'm going to add it to the end of the list using the add method. And I know these methods should already take care of what they need to in terms of making sure the array is big enough, etc. And then shifting the gap. Okay, so either one of these approaches would be correct. I'm going to leave this approach in place. And I'm also going to decide that perhaps I do want to flag my user if this didn't go successfully. And the way that this wouldn't go successfully is through, just shift up, look at the add method for a moment here, is if they have an empty list or a list of one, size 1. So what I can do in that case is I can just return false to indicate that nothing was changed about the list. Now you might argue that if it's a 1-element list, you do still want to return true because technically they did move that one item to the end of the list, but nothing was changed about the list. So you'd want to put some comments in here to indicate what is meant by true and false. Or alternatively, you could just leave the method void and not send back any information. Different design decisions and different people will make different choices. Okay, so that is the moveToEnd method. Next up, I'm going to make a swap method. And here I am definitely going to want to return a Boolean to indicate whether or not my swap was successful. So I want to take in 2 list positions. And then I'm going to swap the content. So if I take in 3 and 5, I want to put the element that's currently 5th in the list in the 3rd place and the element that's currently 3rd in the list in the 5th place. So what do I need to do first? Well, the first thing I need to do is I need to make sure that both of these are valid positions. So I need to make sure that first position is greater than or equal to 1 and first position is less than or equal to number of entries. And I need to make sure that second position is also greater than or equal to 1 and that second position is greater than or equal to, less than or equal to number of entries. So I need to make sure that all of my position indices that you give me are accurate, valid positions. And if that isn't the case, I could return false. But what I also want to do is I want to keep consistent with the design of the rest of the class. And we see that in the other methods in the AList class, when something goes wrong with the position, what happens is we throw this exception, this illegal out of bounds exception. So in order to stick and make this class consistent, instead of returning false in my else statement, I'm going to throw that exception. Illegal position given to the swap operation. Again, you could return false. That wouldn't be incorrect, but it wouldn't be consistent with the design approach of the other methods. Okay, so assuming I do have the correct position or valid positions that are given to me, what I can do is I can create a temporary placeholder object of type T, and that will temporarily store the list at the first position. So whatever is in that first position, we'll put it in a temporary placeholder. Then the list at that first position will be given whatever is currently at the second position. And then the list at the second position will be filled in with that temporary placeholder. Recall that you need 3 variables to swap 2 items. If you're not sure why, post a question about that to the discussion board. And then if that goes correctly, I will return true. Okay, so there is a swap method. You could also make the argument that this method should be void. Again, just a different design decision. Okay, and finally, I'm going to create a method to return a brand new array AList that holds type T that contains all of the elements on the current list that are less than some item you give me. Okay. So you're going to give me some element, and I'm going to give you back a list that contains everything that's less than that entry you give me. So if, for example, my current list has 1, 5, 8, 2, 5, 4, and you send in entry equals 4, then my new list is going to return a list that contains 1 and 2, because 1 and 2 are on my list and they're less than entry. Okay, so basically what I want to do is cycle through my current list and pick out everything that's less than the parameter and create a new list and return that list. Okay, so the first thing I need to do is create a new list. It's going to be empty at first. And then I want to use a loop to loop through my current list. I want to loop starting at position 1 because that's where my list begins. I want to loop up through as long as 1 is less than number of entries, incrementing each time. And then I will create a temporary variable, current item, which is the list at position I. Now I need to compare this current item to this entry to see if this is smaller than that. And if it is smaller than that, I want to add it to my less than list. Okay. Now, how do I compare objects? Well, I compare objects with the compare to method, but I don't know if my list holds things that implement comparable and thus have a compare to method. So two approaches to changing this, I could say that this AList class is only going to contain things that are comparable, which I would do that by changing the class header, like this. And I would probably want to change it here as well. I could do that, but that's one approach. The other approach, if I want to make things a little bit simpler, is I can just say, well, if you want something that is less than some other entry, then you have to give me a comparable object. And now I know that entry has a compare to method, so I can invoke compare to on entry, and I don't have to worry about invoking it on current item. Now, really, both of these things should implement, both these classes, this one and this one, should implement comparable, right? Because if we want to compare things, that's the only way we know how to do it, is by implementing comparable. So really, if you want to make a full and robust solution, you'd want to make both those changes. You'd want to change your class to have T implement comparable, or in the syntax we use for generics, T extends comparable. And you'd want to make this change to only take a parameter of type comparable. Because I don't want to change our general AList class, since we're going to be using this code for other things, I'm not going to make that change to T. But just know that that would be kind of the most robust way to design your solution. So what we can now do is we can say, okay, well, if entry, if you compare that to the current item, and if we want to know if entry is bigger than, right? So if entry is, if we compare those and the result is greater than 0, this means that entry is bigger than the current item. Then that means the current item is less than entry, and so we'll add it to the less than list. And then after I go through my whole list, I just return my less than list. Now, do I need to do any special considerations for an empty list? Well, an empty list, number of entries is what? Number of entries is 0. So for my for loop here, I starts as 1. 1 is not less than 0, so the for loop will just never be executed, and we'll just return an empty list. And that makes sense, right? Because if I have an empty list, and I want a new list that has everything less than some item on the list, well, that's an empty list, because there's nothing less than that item. Okay, so I don't need any special considerations. This code will run fine on an empty list. It won't crash, and it will return the logical answer that it should, which is an empty less than list. Okay, so there is the implementation of 3 additional methods to the AList class. Post any questions about these methods to the discussion board.